Hi everyone, good day. I am Ayorinde Olatunde. I'm an applied mathematics PhD student in Case Western Reserve University. And prior to that, I held a Master and Bachelor of Science in Statistics, respectively. Today, I'm here to give you a gentle introduction to statistics and exploratory data analysis in this data science for social impact. And just follow me as I lead you on gently introducing this subject matter. So, what is statistics? Statistics, for short, is COSPA, for you to be able to remember using that main unit. Statistics is the science of collecting, organizing, summarizing, presenting, and analyzing data. Very soon, in slides that are ahead, I will distinguish the difference between data and information. So, telling us that the aim, the goal of statistics is for us to be able to move from data through information and knowledge to applied knowledge, which is actually making decision. And by the time I start explaining the basic terms in statistics, you will appreciate this aim very well. So why do we do statistics? The real essence of us engaging in statistics is for us to be able to scientifically learn and gain insights about the whole from its parts. The whole, we refer to that as the population, while the parts becomes the sample. And why do we need to do that? We need to do that because if we are working with the parts, which is called the sample, to gain insight, information, knowledge about the population, which is the whole, we are able to save time, we're able to save money, we're able to save the number of professionals that are used in conducting such a study. And statistics have actually been widely used in almost all areas of research. And many areas of research rely heavily on statistics, while some, just take a little bit of it. So researchers and analysts actually use statistics to be able to derive meaningful findings, identify patterns, and make informed data-based decisions. So we now look into what I've been talking about, which I really want to explain at this point. What do we mean when we talk about population, when we talk about data, when we talk about sample? Before I go in depth explaining that, let me just give, using the, you can see my cursor now on the types of statistics. Let me just briefly explain the types of statistics we have. Then from there, I now go in depth to really demystify, what we mean when we talk about data, when we talk about population, we talk about sample. Because once you understand these three terms, you're able to follow along. So types of statistics, we have descriptive statistics and inferential statistics. So descriptive statistics are things that we are able to use a kind of quantification based on the data we have from the sample to make decision about the population. Very soon you understand sample, population, data. I will explain that just in a moment. So descriptive statistics, again, that is split into two. We have measures of central tendency and we have measures of dispersion. So for central tendency, we have mean, median, mode. You must have been familiar with that now from your basic algebra and what have you. Then for measures of dispersion, we have range, standard deviation, variance, a lot more. At the end of this tutorial, there are some links where you can read more about all of this. And when we talk about inferential statistics, we're talking about things like confidence interval, hypothesis testing, regression analysis, analysis of variance, multivariate analysis of variance, analysis of covariance, and a whole lot more. So now, let's dive deep to give real information about these three things that needs to get you started with statistics. So when we talk about data, what are we talking about? Data is actually raw information that you gather through observation, through experiment, through surveys, and other sources. So it can just be age. Maybe you are conducting a research, you go to a class, and you just gather the age of individuals in the class. That is data points. It can be the price of an item. It can be the height of buildings. It can be the amount of pH in a soil solution. Anything that you are just picking the values or you are recording the features. Take, for instance, you may also enter a class and say, okay, we want to count the number of boys, we want to count the number of girls. Things in such ways that you are just getting through observation, experiment, surveys, and other sources. These are data points. So it can be numerical. That means it can be amount, it can be measurement, something that you can put a number to. And it can also be qualitative, something that you really cannot call a number. For instance, it can be features, characteristics like sex, and the state from which someone came from. Maybe you are looking at a cross section of US citizens. You want to look at which state are they coming from. These are features, these are characteristics. So that is data point. So when we now talk about from data, the other time we talk about true information. Information now is when you process this data, you organize it, you arrange it, you sort it together. You are now trying to put contexts into the data points. So at that point, you are moving from data, just the records, putting context into it, arranging it, putting it together, classifying it. You are moving into information. Then from there, you want to think about, can we analyze this? Can we gain insights from this? And that now talks about population and sample. Actually, the subject statistics could have been called parameter. Like as you are hearing statistics, 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 probably today you'll have been hearing parameter, parameter, parameter. But it is statistics. Why? Because that statistics is the estimate of the sample. What are we saying? Is that when you pick that part, because it costs more money, it costs more time, it costs more. Whatever you want to think about, it will be more to deal with the entire population, to deal with everything that you want to make inference about, to deal with everything that you are really, really concerned about. So since it will give more costs or it will take more cost, we do not have the luxury of time, the money, and all the rest to pursue research on the whole population in almost all cases. So because of this, a portion of that whole, a portion of the entire is taken. And that portion, that subset, is what is now called sample. So it is from the sample you get the data point out. And by the time you analyze, arrange, summarize, present, all that you have from the sample, you're able to draw inference about the population. So you now want to make scientific statements about the population. So take, for instance, let me contextualize what I'm explaining. Take, for instance, you want to know the average age of all the people in the United States of America. Instead of going over the 300 and something million people living in US, you can go over the 50 states, pick a representative portion in each of the states. And from there, get their age, find the average. And from there, you can now move from the sample you are working with and now make a conclusion with the probabilistic statement on the population, the mean of the, of US citizens or people resident in US. So that is what we're talking about, that we want to pick a subset of the complete group. That complete group is the population. The subset is the sample. And we want to make inference. We want to make probabilistic statement. We want to make conclusions on the whole using the parts. So the part is the sample, the whole is the population. When you study the sample, whatever estimate you are able to come with, what we mean by estimate may be mean, median, mode, standard deviation, range, and all the things we talked about, ahead. I'm talking about all of what we have here, measures of center tendency, measure of dispersion, and all the rest. So whatever you are coming out of there become the sample statistics. Whereas what we want to draw conclusion about is the population parameter. So I believe you understand in a very clear way the difference between data and information and difference between population and sample. So with that in view, now you now see that descriptive statistics, these are tools that we use to be able to draw inference from the sample to the population. A lot of them, mirror center tendency, we talk about them, mirrors of dispersion, we talk about them. You can use frequency plot. Like, apart from dealing with the figures themselves now, you may want to visualize. You may want to see how these are. You want to see it with your eyes. Then that is when you come with plots and all the rest. If you want to read more, just look at the link here and you will learn more about descriptive statistics. So other things we've talked about, statistical graphs and charts, that is for you to visualize how your data is behaving. Then inferential statistics, we've talked more about this, is that you want to make statistical or scientific statements on the population based on the sample. So that is where inferential statistics come into being. And probability means, as you are making this statement, you want to give us the measure of assurance that, okay, I am 95% sure of what I am saying. I am 85% sure of what I'm saying. In the earth sciences, they always use like 99% because they are dealing with life and they have to be very, very accurate. The hypothesis testing is that by the time you are formulating your hypothesis, your question of research, you also want to test against the null, that the status quo you are believing that is true. By the time you are done with your analysis, you want to test if the initial assumption is true or not. And that is where hypothesis testing come into play. And whereas correlation and regression is the features you are using to do your analysis. You want to look at them. Are they related at all? That is, are they correlated? When you want to look at are they related, how do you form an equation that you will use to measure if they are related or not? That is where your regression comes into play. So the regression is giving you the equation. Then again, you may even want to look at what is causing what. Who is depending on who? If a parent is the one giving pocket money to the child going to school, who is depending on who? Definitely, it is the child that is depending on the parent. Then you may also want to investigate, is there any causality effect? Like, is A causing B? And because it is possible that two things are depending on each other and none is causing the other. So all these things are, areas where we can study into to gain insight about our data set. So we move now into the introductory part of the exploratory data analysis. In this part, in brief, I will tell you there are two things we want to look at. First, we look at the data point itself, the numbers, how many rows do we have in it, how many columns. You just want to look at the numbers. We want to explore the data using numbers. On the other way around is trying to explore it with visual aids. The second part, I will not talk more about it, even though I have it here in my slide, because one of my colleagues will come in a later tutorial to deal more on that. But just for you to know that there are two areas when you talk about exploratory data analysis. You want to first look at the numbers. You want to look at the structure. You want to look at the descriptive statistics. You want to look at the figures. Then on the other way around, you also want to look at it visually. So I'm moving now. To do this, why do we even do exploratory data analysis? We do exploratory data analysis because, one, we want to discover pattern that is in our data. Don't forget what we talked about the other time. Data is just record of numbers, features, characteristics, and all the rest. Just spitting out the figures, spitting out the features, characteristics. So, but by the time we now want to aggregate all these data points for us to be able to learn, for us to be able to put it into context. So we want to discover pattern in it. So number two, we also want to observe what we have recorded. Do we have real events? And again, I mentioned hypothesis the other time. Maybe you believe that the age of people in an environment is averagely less than 20. That may be an hypothesis. You want to test it. Is that true or false? So you use it to test hypothesis to check if your assumptions are valid through your summary statistics and graph. So why do we do EDA? In one word, we are just saying it is for us to better understand the variables and the relationship between them. So it's just like a kind of question. Your EDA is like a kind of question that you ask successively to be able to guide you to the right analysis to do when you want to go into your main analysis. And finally, it helps you to clean up your data and, give you a good understanding of how your data behaves. So with EDA, you are able to reduce the features to vital few. This is saying that while measurements are being taken, some redundant, unneeded data points might have been captured. You want to reduce it to the vital few. Again, why that is being done, because we are humans, we are susceptible to error. There might be human error, there might be a lot of missing value and a lot of other things. You want to identify these things at this level. Then you also want to understand if there is relationship between your variables. You also want to minimize potential error in your main analysis. So EDA, for short, is helping you to draw relevant information from your data before you go into the real analysis for you to be able to make sound decisions. So to do this, I'm going to use the Palmer Penguin library R, which comes with Penguin's dataset. So the dataset contains 3 measurements from 344 penguins, talking about the species they come from, the island they come from, giving us body measurements, giving us a lot of other things that you will see as we move on now. So for you to go into your analysis, by now you have been introduced to R. First, you have to install your packages. That is what you see in line 1, line 2 to line 6. So you see, I've installed my packages. I'm not doing that here because I have it here. That's why you see the hash in front of each of them. But in your case, you may not need to put the hash, and from there you install the required package. Then after installing the packages, you need to load the packages. So you can see library tidyverse, library Palmer Penguin, library cable extra, library scheme R, and library dplyr. So once you've installed and load your packages and libraries, the next thing you want to see is you want to import your data set, the data you want to use. In my case, again, I'm not importing it because This is already inbuilt in the package you are using, but in your case, you may need to load the data set. So since this is already there, all I just need to do is write the code data and Penguin inside it. From there, I am able to get the data set. And if you want to see more data set that are inbuilt in R, just use this code, the code that I'm highlighting here, that is data, and put the two brackets in front of it. It will bring out data sets that are in R for you, with which you can do practice on your own. So I want to look at the structure and also try to give a context to the data we are working with. So the structure of the data and the definition of each of the features here. So to do that, just use the code that is, you can see where my cursor is, str, that is structure, penguins. From there, it will give you all the structure, all the features there, that is the columns, the data set, telling you that species, it is a factor variable, with 3 levels. Island is a factor variable with 3 levels. B length is numeric, and we have 344 of them. B depth, flipper length, body mass, sex, and year. So this is the definition of each of these things. The species is actually a factor variable representing the penguin species. This data set have been used a lot, or will still be used more in this series of tutorial. So it's good to get familiar with what each of the column is talking about. The island is also a factor variable representing the island from which the birds are coming from. While B length, B depth, flipper length, they are all numeric variable representing the B length, the B depth, and the flipper length. The body mass, that's the mass of the bird, and the sex is the sex of the bird. And you've been seeing factor variable, numeric variable. What do they mean? So let me just tell you here. When we talk about character, character has actually words or string of words, like maybe names of persons or names of states. Maybe you are capturing data set and you want to record the state from which each of the respondents is coming from. So Ohio, Iowa, Washington, these are words. So when you are storing that in your data set and we are reading it in R, it becomes character. And since they are character, you can actually factor them. So that's why we said it can be transformed into factor variables. So that's when you're talking about a factor variable with so number of levels. Then factor means you are using, these are categorical data. So just like states, Iowa, Ohio, Washington, they are factors, they are levels. Just factor them into levels. And you can just use integers to denote them. They are not ordered. Take for instance for states, but there are some also that are ordered with other examples. So that means your factor variable can be ordered, and it's also possible for it not to be ordered. Now, finally, you have numeric. So just like maybe you are talking about age, so you can see that age, it has order in it. Someone that is 20 years is younger than someone that is 30 years. So numeric can be continuous, it can be ratio, it can be interval, and these are types of variable that you have. So now, for the data we are dealing with now, you may want to know how many rows, that is, the rows is talking about each individual observation. You may want to know how many columns. Columns is talking about the number of features that are recorded from each observation. Let me explain again. Observation is each item, each unit, each element in your experiment. Like if you want to get you want to get some features about people living in a state. Each person is an observation. So when you're not talking about the features, these are not the things we are recording from each person. So take for instance, you get to one person, you talk about his age, his height, his sex, his salary range, and all those kind of things. Those are the features. Those are the characteristics you are recording. So when you are representing that, that becomes columns. in your data set. But each person that you are meeting, the experimental unit, that is uh, the one that is in the rows. So now, dimension penguins, you have, it's this is like a matrix. You have row by column. You have 344 by 8. So meaning that there are 344 individuals. In the case of the data we are dealing with, there are 344 penguins, and there are 8 features that are recorded on each of them. Very soon you will see it downstairs. Then again, you can use the code end row. You can see my cursor, end row, penguin, that will tell you it's 344. End column is to tell you it is 8. So, and there is a way you may want to look at the data set as a whole, just at one glance. To do that, you use this code that we have here. That is our, cable. The cable is just for us to arrange it neatly in this format. Very soon, I will show you the difference between when you use cable and when you don't use cable. That will show you how the beauty of using cable as a package in R to make our presentation very neat. So head, it's the major thing here, the major code here is head, penguins, and 5. Meaning that we want to see the first 5 rows in the dataset penguins. And with the first 5 rows now, it tells us that, okay, we have the species that is island, bill depth, bill length, flipper length, body mass, sex, and year. So each of these columns is what I was talking about the other time. Those are the characteristics, the features: year, sex, body mass, body length, bill depth, bill length, island, species. Now, for each of the rows, like you have row 1, the one that is highlighted yellow now, row 2, highlighted yellow, just like as you see each of the highlights, those are now individual penguins that you are recording all those features: species, island, bill depth, flipper length, body mass, body sex, and year about. So when you see NA, it means there is no value there. That means that's a missing value. So again, as you can see the head of the data set, in the same vein, you can also see the last rows of the data set. So in the case of the first one, we used head. You can see it here, head. And in the case of the second one, you just use tail. From tail, you're able to see the last 5 rows. And you can increase the end to 10, 15. You see the last 10 or 15 rows. So after this, you look at how the data look like. You also want to know, you may want to go deeper into each of the column, like species. You want to see how many levels do we have. You can summarize it, and that will tell you, like here now, you say level of penguin. The $ is telling you that go inside the penguin data set, go to the column species, then tell me how many levels we have there. So that bring it out: Adele, Chinstrap, and Gento. Then N levels is to tell you that how many levels do you have. Just tell you, okay, you have only 3 of them. Then this is to filter for you to know, do you have a missing variable? That is .NA. Then before I move on, I want to explain this percentage greater than and percentage sign. Yes, I mentioned the word percentage greater than percentage, but that's not how you call it when you are really doing data science. You call it piping. What is the work of piping in R? Piping is a very great tool that help and make our coding very neat and very sweet. It is trying to tell you that, okay, go to penguins. When you go to penguin, take the next action. So that's the work of that piping. And what's the next action? Filter. So it's like trying to tell you that if you want to do 3, 4, 5 things at a goal with just one line of code, you can use this piping. So when you see greater percentage greater than percentage. It is technically called piping. So the work of piping is to move from one function to another one, and finally to the last one and bring the result out. Very good uh, uh, tool that we use in R. So we move on again. You can see the mean of, if do we have missing value, it brings that out. Then again, here you want to count. As I mentioned the other time, you want to count the penguins, species, and island. And from here, you pipe it through this cable function that I've mentioned over and over. It helps you to go inside the data penguin, categorize with species, with island, and help you to count out what you have in each cases. Then again, you come here. I mentioned the other time that cable is just for us to present our result in a very neat way. Like you can also find the summary of your data set, like what is the maximum value if you have a numeric variable, what's the maximum value, what is the minimum value, what is the median, what is the third quartile, what is the first quartile. You may want to know all those things. And if they are variables that are non-numerical, maybe they are categorical variable, you want to check how many do I have in this category? How many do I have in that category? So to do that, you just use the command summary. You can see it here now. I am highlighting it, summary, and just put the data, what we've saved the data as, and it brings out the results. So you see the species, it tells you that Adelaide has 146, Chinstrap has 68, Gento have 119. Highland, it tell you from Bisco, you have 143, Dream, you have 123, and Toxin, you have 47. Just like that, B length, it will tell you the minimum value, the median, the mean, the third quartile, the maximum, and on like that. And if you now go down, you see, the first one, I just use the command summary with Penguin. Then you can now see when I use that same command summary, but now with cable, you can see how it arranged it neatly. That's just the work of cable, just to arrange our result in a very neat and nice way. So we move on again. Again, don't forget I explained the work of pipe, that you move, like here now we may want to select. Maybe you want to select species, island, B length, and B depth. So what do? You go inside Penguin, pipe it, and tell him that after getting inside Penguin, go and select the following species out for me. And it does that for you. So all these things, you are just trying to look at the features, the characteristics, understanding the figures. How do this data set I'm working with, how does it summarize? Then again, you can use that command group by. So you want to group a variable and calculate the summary statistics. So you want to say, okay, take for instance, maybe you have recorded the sex of 1,000 people. Instead of just knowing the average age of everybody, you also want to look at, can I know the average age of males? Can I know the average age of female? So you can group by sex, and from there find the average age of each group. From there, you now want to understand, okay, are the males, are they younger than the females? Are the females younger than the males? So that's the beauty of this type of function. So you group by. Again, don't forget piping, very useful. Go inside Penguin. Then after going inside Penguin, group by species. After grouping by species, piping again, summarize. How do you summarize? Summarize with the mean of B length, summarize with the mean of B depth. But as you are doing this, you may have some missing values. So NA.remove is saying, when you want to calculate the mean, remove the missing values so that it will not return error for us. Because if this NA.remove is not there and we have missing value in our data set, it will return error. Because if you want to add, let's say you have 3 data points, 1, 2, 3. The first one, you have a number. The second one, you have a number. The third one, you don't have a number. By the time you are adding the first and second, it will give you a number. When you want to add with a missing value, it returns an error. So the any.remove is telling the code that when you see missing value, remove it and continue with the ones that are not missing. So from there, you're able to find the mean of each of the group by this function. So don't forget piping, very useful. Then all what we've been doing, trying to understand the figure and not the rest, you can also do with scheme R. And the beauty of scheme R is that apart from giving you all what we have seen, it will also give you a kind of histogram of each of the population. Then like when we're talking about the other time, or the sample rather, when we're talking about the other time, we see the minimum, that is P0, maximum P100, first quartile P25, median P50, third quartile P75, and all the rest. So all of what we've been doing so far, you can also do with scheme R, and it will also give you all the results. So now, visualization. Again, I repeat the other time that I will talk more about the data points, how you can summarize and all the rest. For the visualization, I will not talk more about this because one of my colleagues will come in a later tutorial in this series of lectures to go in depth on this. So, but just like an overview, the same way we can deal with the numbers and, find the mean, the median, the mode, standard deviation, and all of that things to be able to understand the data point, we can also create plots that can, make it visual. In fact, you don't need to be understanding and be on trying to understand what the numbers are talking about now. You can actually see them, with your eye. So we have a lot of them. Pie charts, we've been dealing with it. Pie charts is just like circles. You want to look at the proportion of each one. Then you see bar plot. Bar plot is there to tell you, again, I repeat, I'm not going in there because someone is still coming to come and do this in depth. So, but bar plot, you also want to represent them each by the frequency in each of the bars. And there are a lot of ways you can work with this. My colleague will tell you about ggplot, represent them, break them with group, and histogram, still doing the same thing if you are dealing with continuous data set, and you can do a lot of transformation. Very soon, you will see all of this in one of the tutorials coming. Box plot, this is to tell you, do you have an outlier, and how is the data set distributed? And that also will tell you, like in this case now, you have two dots in the Shinstrap species. The two dots outside the boxes is trying to tell you that for this particular species, you are actually having a possibility of outliers. Then violin plot is trying to mix both box plot and histogram together, and telling you again how they are distributed, where is the where is the median. Then density plots, just trying to give you the density. Where are they densely populated? So from here now, you can see that the Gento, that is the one that seems like blue, is somewhat out of, separated from the other two. Whereas Adeli and Shinstrap, they are almost together. So all these things, my colleague, we talk more about them. Then you have scatter plot as well, trying to tell you, the pattern, the direction, and the strength of their relationship of, one variable to another. From here, you can see examples here, and you can still separate them by groups, and you can separate by groups. Apart from group, you can do a lot of deeper separation. My colleague, again, will go into the in-depth of how you do all of this. So summarily is that depending on the kind of data you want to analyze, there are many plots that you can get. There are many statistics that you can bring out. Then one note of warning is that there is no standard way of doing exploratory data analysis. It is the research that you are doing, it is the data set that you want to analyze that will determine the set of exploratory data analysis that to get involved with. So there are still many things that we've not talked about here. We have correlation plot, heat map, line plot, just a lot and a lot and a lot that can still be done depending on what you want to do for you to be able to understand the data that you're working with. So with this, we come to the end of the tutorial. These are glossary of the major basic terms that we discussed, and we've added some more links at this point so that you can go over them, read more about it. And if these are not, if after going through all these links here, you still want to learn more, we now have further resources that will take you deeper into statistics and exploratory data analysis. Thank you for your time. Have a great day.